So I've got a few minutes for the bell to leave, and I thought I would do this. 15, we're going to have to find an angle that lies between 0 and 180 degrees. And if you've been remotely conscious during class, you know the calculator might tell you the answer. And generally speaking, use what it gives you as a reference angle. All right? So that's what we're going to do. We're going to go push some buttons on a TI-84. Now, the answer's got to lie between 0 and 180 degrees, all right? So let's push buttons. We're doing the arc tangent of negative 6.45 such that the angle lies between 0 and 180. And it gave me that. It gave me about negative 81.19 degrees. So again, that's from the TI-84. About negative 81 point, I think I said 19 degrees. Yeah, 19 degrees. Now, up top, it talks about the angle lying between 0 and 180. This means it's in quadrant 1 or 2, and that answer surely is not there. Now, I'm going to write down the old acronym, all schools torture children, and I notice that this is negative, which means I'm here, because quadrant 1 is all ratios positive, quadrant 2 is sine and cosecant positive. So my angle is going to have to be in this quadrant, okay? This is my angle. Starts here, rotates to there. So I suggest using as a reference angle. We're just going to ignore the sine. The reference angle is 81.19, which means the angle is all of the straight angle with the exception of that piece. So it's 180 minus 81.19. Which is what, 98.81? Don't believe me, push some buttons. 98.81 degrees. I think I'm right on that. I feel like I'm right on that. So that's how you do 15. Now what we got on 16? 16 is evaluate the arc-sine ratio such that the angle lies between 0 pi and 2 pi. And I'll do this two ways, okay? I will do this two ways. I will do it using the classical approach, which is to draw triangles, and then I'll do it using the unit circle approach. Now I notice that this thing is negative. That's what I noticed, it's negative. All strippers take cash. By the way, I associate sine with y. And y is negative here and here. Tangent, cotangent positive, cosine, secant positive. So I've got to be in one of these two quadrants. So I know that I've got an angle that rotates here, and I've got an angle that rotates here. These are my angles, okay? One of those two. So I go to my TI-84. By the way, look how I want this answer, pi rads. And it's going to return an answer in quadrant 4. That's all it's going to do. Don't believe me? We'll push the buttons. You'll see. It will hopefully return negative 60 degrees. That's what it should do. I've been pushing buttons on TI-84s for a long time. Negative 60, which I'm going to use as a reference angle. And if there's 60 degrees here, there's 60 degrees there. So let's talk about the full angle here. Come here. Come here. I want you. There we go. All but 60. One angle is 300 degrees. 180 plus 60. The other angle is 240 degrees. Now, I want these as pi rads. So 300 degrees times pi over 180, or maybe do some memorization here. 300 degrees ought to be 5 pi over 3. 240 times pi over 180, that ought to be 4 pi over 3. That's what it should be. I notice they differ by 60 degrees too, kind of interesting. Anyways, the other approach to this is to use your unit circle. Let me grab a unit circle here. Oh, those are grades. Not what I wanted. Thought I had the unit circle up. If your grade was displayed there, sorry about your grade. That's the grade you earned. On the unit circle, this question is asking what angles have a y value equal to negative square root of 3 over 2. So what y values have a negative square root of 3 over 2? Right there, right there. And you'll see that they're the 5 pi and the 4 pi over 3. The unit circle is going to make your test on either Wednesday or Thursday, depending on which period you're in, or what day I actually decide on it to be, easy. It will. That's what it's going to do for you. Given that tangent of alpha is negative x and alpha lies in the fourth quadrant, find the sine of alpha. So we'll throw that over a 1, and we know that tangent is opposite over adjacent. Fourth quadrant, you numbnuts, 1, 2, 3, 4. I draw a triangle in quadrant 4. Opposite over adjacent, we're going to put what's called alpha prime in the corner. Doesn't really look like a very good alpha prime. It's supposed to be, but it looks horrible. Opposite over adjacent. We're going to do a little bit of Pythagorean theorem because sine is opposite over hypotenuse. So we're going to be like a negative x squared plus a 1 squared is a c squared. That's x squared plus 1 is c squared. The opposite of squaring is square rooting. And there is my hypotenuse. And I'm going to do the sine ratio, which is opposite over hypotenuse, negative x over that ugly looking thing. And that's how hard this problem is. It is easy peasy Japanesey. Moving forward with my life, don't know about yours. There she is. Alex props a ladder against a wall. The ladder makes a 27-degree angle with the ground. So he puts a ladder against a wall. It forms a 27-degree angle with the ground. The wall is preferably perpendicular to the ground. The ladder is 22 feet long, and I want to know what is the expression for finding the distance the foot of the ladder is from the wall. So I will know this distance right here. And what I have is I have a hypotenuse, and I have an adjacent side to that angle. And again, I'm thinking about SOHCAHTOA. Like, don't make this harder than it has to be. I understand the year's almost over. You're sitting here done. I can think of 5 names on the top of my head that if they don't hurry up and get their crap together, they flunk for the year because their last 6 weeks they haven't done anything. They were passing all year long, and you're going to throw it away at the end. It's not how you do it. But if I have the A and the H, then I have the cosine ratio. The cosine of 27 degrees must be x over 22. You know, that doesn't help me here, but I know that the opposite of division is multiplication, so I 22 both sides, and that's what I'm looking for. 22 cosine is 27, choice A. Moving forward. Last couple of questions here until I do the bonuses are all ACT style questions. In a triangle ABC shown below, the measure of angle B is 55, the measure of angle C is 43, and A to B is 42 units long. Which of the following is an expression for the lengths in units of side BC? This is a law of sines problem. You see that relationship right there? That's sines. This is not right, by the way. It is not a right triangle. It is not SOHCAHTOA. It is law of sines or cosines. But the sine of 43 compares to 42 as, what do I want here? B to C? I want that question mark. I got to have that angle. So, you know, if I put 43 and 55 together, I get 98 degrees. If I do 180 minus 98 degrees, I think I get 82. 82 degrees in the corner. As these two are related, as the sine of 82 is related to that question mark. And then I do the old cross multiplication mark. Question marks, sines of 43 degrees are equal to 42 sines of 82 degrees. And then I divide out the sine of 43 to get that question mark. So I'm looking for 42 sines 82 over the sine of 43, choice C. And I am moving forward. In the right triangle shown below, 0 is less than B is less than A, and one of the angle measures in the triangle is the arctangent of B over A. And what this is doing is this is asking you to find the angle where opposite over adjacent is equal to B over A. Now, if you're thinking like I'm thinking, that's going to be this guy right here. All right? Opposite adjacent. So it wants the sine of that ratio. See what it's saying? It's saying, no, if you figured out where you're at, and now it's saying, find the sine of that angle. This is kind of a hard thing for kids to interpret. What is the sine of an angle whose tangent ratio is B over A? Maybe you need that. That says what this is. What is the sine of the angle whose tangent ratio is equal to B over A? But it's this angle right here. And let's just give it a name. Let's call it big B, because it's opposite of angle B. Anyways, let's do this. I need this little guy right here. I'm going to have to do a little bit more of that Pythagorean theorem. This one is literally a squared plus b squared equals c squared, right? So c is the square root of that. This is an ACT style question. And I want to know the sin of b. Well, I know that the sine of an angle is the opposite over the hypotenuse. That's opposite. That's a right angle, so that's the hypotenuse. So it's going to be little b over square root a squared plus b squared. Done. Moving forward. Last one before I have to do bonuses, I think. I think the next couple of pages are bonuses. Is write the inverse of this function. And we're going to do our 3 steps. We're going to swap x and y. We're going to solve for y. And then we're going to use correct notation. And this notation here would be h to the negative 1 of x. All right. So we literally get the h out. X is 3 tangents of y minus 2 plus 5. And we're going to do 2 easy baby steps. We're going to move that 5 over. It's easy to counteract addition. So 3 tangents of y minus 2. Then we're going to divide out that 3 because the opposite of multiplication is division. X minus 5 over 3 is the tangent of y minus 2. And now we're going to do the opposite of tangent, which is arctangent. We're going to take the arctangent of the left and the right, because you have to have equality. Annihilation happens. The arctangent of x minus 5 over 3 is now equal to y minus 2. We're going to add 2. The arctangent of x minus 5 over 3. Let me just redo all that. I'm in a hurry. The bell rang. I want to go home. Forgive me. Arctangent over 3 plus a 2 is going to be solve for y, so correct notation. There you go. Now, the next video I do will probably be tomorrow morning, and it'll probably be where I do the bonus questions. Because, I know you want those bonus points, right? Nobody's going to look at it.